Bismillahirrahmanirrahim. Today we are going to do assignment 7.3. The statement of assignment 7.3 is calculate the work done in stretching a wire of length 5 meter having a cross-sectional area 1 millimeter square. When the force applied by you on edges of wire produces change in the length of wire by 1 millimeter. Young's modulus of wire is 2 into 10 raised by 11 Pascal. The situation which is given to us is that we have a wire which is of length 5 meter, and when a force has been applied on this wire, it has been stretched to a length of 1 millimeter. What we need to calculate is the amount of work done which has brought a change of 1 millimeter in the length of this wire. For this, we can solve it by using the given data. According to the given data, length of wire is 5 meter. Cross-sectional area is given to us. It is 1 millimeter square. But we have to convert this millimeter square into meter square. We know that the value of 1 milli is 10 raised power minus 3. So we have written 10 raised power minus 3 in place of milli. But as you know, there is millimeter square. We have to convert 2 millimeters into meters. That means we have to not only multiply it with 10 raised power minus 3, but we have to take it square as well in order to get 1 millimeter square into meter square. Change in length of wire is 1 millimeter. You can see that there is only 1 millimeter which has to be converted into meters, so we have multiplied it by 10 raised power minus 3. When there was a square, we had taken the power 2 on 10 raised power minus 3, and as there is no square in this term, so we have just multiplied with 10 raised power minus 3. Also, Young's modulus of wire is given to us. It is 2 into 10 raised power 11 Pascal. What we need to find is the work done in stretching the wire, which can also be called as strain energy, and it is represented by U. The formula which we can use for this purpose is strain energy formula. We know that W, we can write it W or U, is equals to 1 by 2 YA divided by L multiplied by del L square. Y is the Young modulus over here. A is the area of cross section, L is the length of wire, and del L is the change in length of the wire. As all the values have been provided to us in the question, so we have to insert the values, value of Y, value of L, A, and del L. We will obtain the amount of stretch which will produce a stretch of 1 millimeter in the wire. That work will be 0.02 joules. Next is numerical number 4. It is related to the same assignment. A rod of 90 millimeter square has length of 3 meter. If the stretch of 300 megapascal is applied to stretch the rod, then find the strain energy if Young modulus of rod is 200 gigapascal. We have been given a rod and its length has also been given to us. When a stress has been applied on it, it has been elongated, it has been stretched. We have to find the amount of strain which will produce in it by the stress of 300 megapascal. So we can write the given data. Length of wire is 3 meters. Cross-sectional area is given to us. It is 90 millimeter square. We are converting into meter square, for which we will write 10 raised power minus 3, and due to square on millimeter, we will take the square of 10 raised power minus 3. And stress is 300 megapascal. Mega means 10 raised power 6, so we will write it in place of mega. And Young modulus of wire or rod is also given to us. It is 200 gigapascal. The value of giga is 10 raised power 9 pascals. We have to find the strain energy which is represented by U, and the formula which we can use for this purpose is by strain energy formula. U is equals to 1 by 2 YA divided by L into del L square. Here Y is given to us, A is given to us, L is given to us, but we don't know the value of del L. How much change in the length has occurred? We don't know its value, but it is given that how much stress has been applied on the wire. So using that stress, we can determine the change in. For this, we will write the formula for strain energy, that is 1/2 YA divided by L into del L square. Y is equals to stress by strain, and by rearranging this formula, strain is equals to stress divided by Y. We have just taken strain on the left hand side and Y on the right hand side. Strain is change in length divided by additional length. We will rearrange it again to find the value of del L. We know that what is the value of stress, what is the value of Y, what is the value of L. We can either substitute all these value in this formula to obtain the value of del L and then insert the value in the formula, or we can do it later on by just putting this formula into this formula. So putting the values, we will obtain the value of U as 1/2 YA by L, and in place of del L, we are writing the formula just determined, that is stress divided by Y multiplied by L. I have written this formula over here because I just really want to simplify this formula instead of substituting values, all the values earlier and then again in this formula. So cancelling Y as it is square on this term, so there are two Y's in the denominator and one Y in the numerator. We will cancel one of the Y with the Y in the denominator. Similarly, we can cancel one of the L and we will be left with 1/2 stress square, because square is on it. One L has been cancelled, so we will left with one L. Similarly, one of the Y in the denominator has been cancelled out. We will left with one Y. And this area has been multiplied over here. Now we know all the values which we need to put in the formula. So we will substitute the values, and stress is 300 into 10 raised power 6, Y is 200 into 10 raised power 9, A is 19 to 10 raised power minus 3 whole square, and L is 3. By substituting all these values, we will obtain the value of strain energy as 60.75 joules, which is the required result.